the registering, 19 have registered out of 21 onto My Labs Plus. So I'm sorry, My Labs Math. So good job for those 19 people. It looks like the two that's not with the 19, it looks like they've registered, but it looks like they haven't finished registering. I don't know. There's two people that are grayed out, and I'm not going to say who they are, but it looks like they need to finish registering. It looks like, I don't know. So I'll keep a watch on that. And if it keeps on going like that, I'll have to email them and see what's up. I don't know why they're grayed out. But anyway, let's go to the outline. Remember, that is the most important thing that you need to look at and that you need to print out. And let's go to handouts. And where is the outline? Generic outline. I think this one has the outline in it. Let me look and see. And it does. And we're talking about 5A, 5C, and 5E. So let's go ahead and go to the ebook. Chapter contents. A, C, and E. So chapter 5, A, e-text. And of course, I know what we're going to be going over, but I like to use the book as a guide so I don't ramble too much and chase rabbits. So, and we're talking about, of course, statistics, and it's always good to go into statistics first before you go into probability. So, what are the important things that we need to talk about with statistics? All right, so here is my whiteboard. What are the important things? Well, the important things, get my handy dandy marker, capital S, statistics. Now, when I go over these questions and these terms and these math terms in chapter 3, or math questions, yes.
Oh, no, okay, never mind. Your camera's a bit lagging, so I couldn't see it for a second.
I know. Just give it a few seconds. I'm sorry. There's nothing really I can do about that. I didn't know it was lagging until last semester somebody said it was lagging. So I guess you can just, follow along and do the best you can with it. All right. Statistics. What is statistics? And when I give you notes and I do notes, I usually tell you this is a good test question or this is a good standardized test question, because some of y'all will be taking standardized tests in the future, whether you're in nursing or whether you take the GRE to get in graduate school or whatever the case may be. And what I'm going over right now, these 4 or 5 words that I'm going over first, they're on both. So statistics with a capital S is the science of obtaining, calculating, analyzing, and I have no idea how to spell analyzing. I think that's right. Somebody correct me if I'm wrong. And interpreting. I don't know how to spell interpreting either. Data. Somebody check my spelling, please. That is statistics with a capital S. Now I'm going to take a highlighter and I'm going to highlight that S because it's a capital S. Lowercase, and statistics is divided up into 2 groups. One is the population, and the other is the sample. Now, the sample is always smaller than the population. If I want to predict for Tri-County Tech students, I might pull a sample at the Anderson campus and survey all the students at the Anderson campus. So that would be the sample. It's always the smaller of the two. Population uses parameters. Did I spell interpreting and analyzing correctly?
I think so.
I hope so. Parameters are variables used in formulas for the population. Variables used in formulas for the population. And they usually are Greek letters. And two examples that you're going to see is mu and lowercase sigma. Mu looks like an M, a cursive M with a long tail. I usually draw mine backwards. I think it looks like this, but I usually draw mine backwards. And sigma looks like a 0 or an O with a pompadour on top. So when you see a Greek letter from here on out, you know it deals with the population, which is the larger of the two. Sample uses lowercase statistics. And what is lowercase statistics? Variables used in the formulas for the sample. Variables used in formulas for the sample. And you usually have letters of the alphabet like X bar and S. X bar is the mean of the sample. S is the standard deviation for the sample. Mu is the mean for the population. Sigma is the standard deviation for the population. So if you're in a presentation or if somebody's talking to you or discussing to you the standard deviation of something and they say that the standard deviation S is equal to 5.2, you know that they're talking about the sample. If they say sigma is equal to 5.8, then you know they're talking about the population. Now, a lot of you that's had Math 120 before, or when I say that, I mean you had it in high school, all right? Or you took this class before. This is another indication, Miss Yoder and people that we were talking about. Math 120 and sociology are not difficult subjects. The problem is teachers have egos and pride, and some let it show more than others. And one of the things that a teacher will do to boost their ego and their pride is they will take their class and make it more difficult. Now, do I teach classes that are difficult? Yes. College algebra is difficult. Calculus is difficult. Math 120 is not difficult. Math 103 is not difficult. Now, how can I say that? Because most of you that have been in high school have had Algebra 1, Algebra 2, maybe some pre-cal, or some of you had, some of you had pre-cal, some of you had Math 120. I'm sorry, probability and statistics. All of those 4 courses make you mathematically mature for Math 103, Math 155, Math 120, maybe if you've had enough algebra, Math 110, but Math 110 is still aggravating to a lot of students. So I should not have a lot of people fail this course. And if I teach it in a reasonable, common sense way, most students don't fail this course. But if I was to get an ego trip and say, well, nobody's going to pass this course, and I make it 10 times harder, then people are going to fail. So you may have had a teacher like that before. Math 120, sociology, let me think, geography. I knew a teacher once. She don't teach here anymore. She would actually try to make geography difficult. And I just don't understand that. But anyway. All right, so here we go. We're starting off with capital S statistics, the science of obtaining. And when you're dealing with this, you're always going to be dealing with the population and the sample. The sample usually predicts for the what? For the population, because of what is the two most important things in our life? Come on, people. You've heard it before. They're a slogan together. What are the two most important things in our lives?
Water and shelter.
Okay, that's important, but not as but these two things help supply those things that you're talking about. Time,
Oxygen,
and what? Time and money. Now, oxygen is important, whoever said that, but we really don't have to worry about it because it's there. When it's not there, we're going to die. Okay? Simple as that. Just like when the end of the world comes, we're not going to know it. It's just going to happen. Nobody's going to predict it. You know how long people have predicted the end of the world? At least since the 30s. Since the 30s, people have predicted the end of the world. I remember Vice President Gore saying by the year 2000, the world would be pretty much gone. Okay? So you don't have to worry about that, because when oxygen gives out, you're going to die or you're going to be already dead, one of the two. But time and money, why are those two important to us? Do y'all like to go skiing? Do y'all like to go to the lake and the beach? And, you know, that's time. If you work all the time, you don't have time for yourself. So time is important to us. And if you have time, you want to have money to what? Enjoy yourself, to pay the bills, those two things. And those two things right there are very important to people. They're also very important to what? Business. Okay, so when I want to find out something about my business, am I gonna survey 5,000 people, or am I going to survey 500 people? I'm going to survey 500, and I'm going to use statistics and probability to predict for the population, for the 5,000. That is why we have probability and statistics. We have probability and statistics, and write this down because I don't have any room here. We have probability and statistics to take the sample and predict for the population to save time and what? Money. So I'll try to write it right here. And we're going to write this in red because I want you to always think about this while we're talking about probability and statistics. Because have you ever heard anybody say, well, when are we ever going to use this in real life? Well, this is why. If some of y'all make it to be in a business, or some of you may be nursing students that work for a hospital, I'm sorry, but a hospital is a business. Taking data from the sample to predict for the population. To save time and money. Now, I guarantee you, some of y'all have sat through a whole semester of probability and statistics and didn't know what it was for. There's your answer. Whether you work at Michelin or whether you are Michelin or whether you are, and okay, you don't say Anderson Hospital, you have to say and med. Okay, and med, or whether you work at Floor Daniel or whether wherever. Those corporations do this. And what is it called in those corporations? Anybody know? Quality what? Anybody? Oh, come on. Some of your parents hadn't worked in this field. Quality what? Okay, I guess not. Quality assurance. Anybody ever heard of that?
Yeah, I've heard of it.
Where have you heard of it? Just curious if you remember.
Just in life, I don't know.
Okay, just heard it, somebody talking.
Yeah.
Quality assurance, taking data from the sample to predict for the population to save the company time and money. And that's basically what uppercase statistics and probability does. All right, let's move on. Is there anybody that's ever been sitting through a probability and statistics course and didn't know this right here? I bet you have. Okay, I'll shut up. Let me move on. Where is my, there we go. We already talked about that. If I mention it, does that mean it's important? Yes. If I don't mention it, then I'm not going to test you on it. Everybody got that?
Yes, sir.
Hubert.
Yes, sir.
Thank you. I appreciate y'all. I appreciate Justin and Miss Gill. I appreciate y'all interacting with me, and with Miss Arabia and Miss Yoder and Miss Oglesby. Y'all the only 5 people that talked to me this morning, so I appreciate that. Go ahead and write these down. No, don't write them down yet. I'm gonna do something different. Random sample. I'm gonna write random sample in red because that's the one that you're gonna see the most of. Random sample. Everything, whatever you want to put, has, and the keyword, the same chance, equal chance, whatever you want to say it, the same chance of getting picked. Okay? Everyone or everything has the same chance of getting picked. Now, it may not sound good and all, but it sticks to you. You'll remember that. If I give each one of you a Post-it, a yellow Post-it note, and I tell you to take your pencil or your pen of dark ink, meaning black ink or a pencil, and I tell you to write your name on it, fold it in half, and then put it in a fishbowl. That is a random sample. Everybody in the group has the same chance of being picked. So names in a fishbowl is a good example of a random sample. Names in a fishbowl. If everybody has the same chance of being picked, then it's names in a fishbowl. That's a random sample. All right, the second thing is a simple random sample. A simple random sample, and a lot of you are saying, well, why is he rewriting these definitions? Because what is my job? My job is to take difficult material and make it what?
simpler.
Make it simpler or easier for a student to understand. My job is not to take a term and to make it difficult. So I rewrite a lot of these definitions. Now, once you understand my definition, then you can look back at the wordy definition and it'll make more sense to you. A simple random sample is the same thing here, only it's a blank has the same chance of being picked. Okay, let me give you an example. Does everybody see? Hold on, I'm moving something here. Does everybody see these three names right here? Arabia, Oglesby, and Stubenhofer. Everybody see those three names? All right, we're going to call this Group A. We're going to call Yoder, McSwain, and Gill Group B. We're going to call Holder, Chadman, and Haygood Group C. I have to hold the cursor on this, okay? Giordano, I love saying that. Giordano, I don't think I said, did I say it right, Miss Giordano? Giordano.
Yeah, you said it right.
Do you speak Italian?
No.
Well, that sucks. Capiche? You know how I know Capiche? From Rocky. Anyway, I love that name. All right. Okay, I'm going to try this. Erosia. Erosia? Did I say that right?
Yes, kind of.
What is that? What origin is that?
Hispanic.
Hispanic.
Yeah.
Well, then I'm not supposed to pronounce that. Arroyo.
Yes.
Arroyo.
Yes.
Okay. Okay. Well, I'll just call you Louisiana. How about that?
That's fine.
Okay. Miss Giordano. Well, I done lost. Where did Miss Giordano go? Okay. Y'all must have went up somewhere else. Okay. These three people, all right, is Group D. And these three people are Group E. And then we'll add Miss Blue to that. So those last four is Group E. And I take a Post-it note and I put Group A on a Post-it note, and I put Group B on a Post-it note, and I put Group C, D, and E on each individual Post-it note, and I put those A, B, C, D, E. I take those 5 Post-it notes and put them in a fishbowl. Does everyone have the same chance of being picked? Yes. So the difference between a simple random sample and a random sample, a simple random sample, I have 5 groups in the fishbowl. Okay, and I have 5 Post-it notes, 5 Post-it notes. So therefore, each one of the Post-it notes has the same chance of being picked. So every one, meaning each individual of the room, is a random sample. A simple random sample is me grouping y'all into groups. I'm sorry, I got to take this away. There we go. And I have 5 groups represented by 5 Post-it notes. Group A, Group B, Group C, Group D, and Group E. And Group E has Miss Blue in it, which means 4. The rest of y'all have 3 in each group. And therefore, everybody has the same chance. Now, why would you use a simple random sample instead of a random sample? To save what? Time and money doing the actual surveys. And the last good one to use is a systematic random sample. Oops, sorry. And what is a systematic random sample? All right, this is a systematic random sample. Let's bring the do jigger back in, and I pick every third person. So 1, 2, 3. Okay, Stubenhofer. 1, 2, 3. Gill. 1, 2, 3. Haygood. 1, 2, 3. Massengale. 1, 2, 3. King. Is everybody with me? Now, everybody doesn't have the same chance of being picked, but this is a good sample to use for surveys, because you're picking every third person or every nth person.
You're talking about one at a time.
Okay, what's going on? Somebody's talking. Every nth person. I'm gonna kick you out, Miss Gill.
You better not die.
Every nth person.
Listen,
Did I ever tell you all the time I was having class and the boyfriend came in and started fighting with the girlfriend? Oh my gosh, it was very embarrassing. Anyway. Okay, nobody cares. All right, so systematic random sample is the third best. So these are the three best: the random sample, the simple random sample, and the systematic random sample. Those are the three best. So that means that the others pretty much suck. All right. So we got random sample. Okay, there it is. A sample random with a computer selects students at random in a simple random sample. Okay, they use simple random sample. Random sample is individual. Simple random sample is usually a group. Now, some books use them interchangeably. In other words, they think a random sample is the same as a simple random sample. Where other books say a random sample is individual, where a simple random sample is a group. I was taught that a simple random sample is a group. So this book looks like that it's using them both in the same context. But whether you're talking about a group or you're talking about individual, every sample of the same size has, here it is, there's a keyword right there, equal chance. Ooh, I can highlight. I don't like that highlight. I really don't like that one either, but I'll take it. No, we're not going to use that. Undo. I can't even get rid of it now.
So a random sample is just an individual, but simple randoming is a group?
Yes. I was taught a random sample is individual and a simple random sample is a group. Now, I remember the books that we used in the past, they would have random sample and then they would have simple random sample. This book doesn't do that. All right. So you might want to make a note of that in your notes. That in some context, simple random sample can mean random sample. Depends on what definition they give you. All right. Systematic, there it is. Convenience. Write down with convenience that it is the worst. Why is it the worst? Well, let me ask you a question. What if and I'll write this down for you because I want everybody to see it. I work at a rock music. That's the real rock. Well, the real rock is really 60s and 80s. 60s and 80s rock station, music station, or radio station, whatever you want to call it. And I am, of course, what they call a DJ, or now they call them radio personalities. Okay? I also go to school, and my teacher told me to do a survey for extra credit or for a project or whatever the case may be. And I'm taking a statistics course, and I decide, well, I got to turn that in tonight, so I got to do something. So I broadcast on my radio station the following question. And I can't spell ing. How many of you enjoy rock music? Why is this? Well, first of all, is this a convenient sample? Yes or no? I'm working at a rock station, and I broadcast the following through my radio show. Is that convenient?
Yes.
Yes. No matter what the question is, I could say, how many of you like ham sandwiches? Okay. No matter what the question is, it's convenient because I have an avenue or a machine or a vehicle to ask a question to a lot of people. How about if you work at a customer service desk and you are a part-time student? If you work at a customer service desk, would you be able to use a convenient sample? Yes. Well, what if you were weaned on a pickle and work in a closet down the hall and nobody speaks to you? Is that a convenient sample? Could you do a convenient sample from that position? No. So a convenient sample is based on your convenience to accessibility to people or who you are, surveying or asking questions or whatever the case may be. Now, why is this inaccurate? Why is it the most inaccurate? Because you're doing a convenient survey. Why is this inaccurate?
Because of bias.
Why is bias? Explain.
Well, if everybody's listening to a rock station, then they're probably going to like rock.
Exactly.
And it doesn't accurately represent the population.
Exactly. That's why convenient samples can be inaccurate. So write that down for convenient samples. It can be inaccurate. Stratified. Differences among subgroups. Okay, I'm going to tell you right now, this would be maybe a voting precinct or this classroom. I break this virtual classroom up into males and what? Females. And I ask you, what TV shows do y'all like? And I decide to, okay, this person likes this TV show, female. This person likes this TV show, female. This person likes this TV show, male. This person likes this TV show. And I have divided the class into male and female based on the survey. That would be stratified. I go to a voting precinct and I ask people, what do you think about this? I don't know, this legislation that's being voted on today. Okay, what do you think about that? And I'd ask Republicans and Democrats and independents and Green Party and whatever parties are represented. All right, I have broke them up into groups, and that's what stratified is. Now, I'm not going to test you on these definitions, but a standardized test would. So you need to put in your notes that the common sampling methods here, that would be on standardized test. All right, now, when does class end? I know we start at 9:05. I believe we end at 10, don't we? Somebody help me out.
Yes, sir.
Okay, so I'm going to stop right there. We didn't get very far. We haven't even gotten through, what is this section? 5.A or 5A. So right now, you still are to read Chapter 5 and Chapter 6. You can go online and play with the homework on 5A, just go to here and go to assignments. And 5A should be right there. You can play with it, but it's not due yet because I haven't finished it. Does everybody understand that? Okay, so I guess silence means everybody understands it. All right, let me get the roll right quick. Shouldn't take long because there's only a few people here. I mean, there's only, okay, shut up. So I'm gonna go to let me turn off the recording and turn off the presentation. And as soon as I get through, if you don't have any questions,